All right, lesson 2 in unit 2 on rational numbers. Today we're going to be comparing and ordering rational numbers. A little bit more of an annoying task here. If you have a calculator, it's not too bad, but still, here we go. We can do this. You just got to focus really hard on each little piece of this to make sure you aren't making any silly mistakes. Going to the top here, let's go ahead and fill out our table of contents. We're going to be doing learning goal number 12, which is I'm able to compare and order rational numbers. So let's head to there. You can fill out your date for today for comparing rational numbers, and we'll go ahead and record learning goal number 12. All right, moving down. Here we go. Comparing and ordering rational numbers. Our vocabulary is rational numbers. We've already discussed that. So let's break down what rational numbers are, how they can be written. So rational numbers can be written as a fraction. Okay. If you can write it as a fraction, then it's a rational number. They can also be written as a decimal. However, not all decimals are rational numbers. So let's look at the 3 types of decimals and pay close attention to which 2 are rational numbers. So the first one type of decimal is a decimal that is terminating, or you might say ends, okay? And this is just something as simple as, 0.5. It stops, it ends, it's the fraction 1/2, and that's it. The other kind of decimal that is rational is a repeating decimal. Okay, and so these are decimals like 0.3333 and so on, where just this 3 is repeating. Okay. So that is the other type, because that's just the fraction 1/3, okay? And because it can be written as a fraction, that is a rational number. So both of these, if you sort of box this, these are the rational numbers. These are the 2 types of decimals that are rational numbers. The one type of decimal that is not a rational number are decimals that don't repeat, but never end, okay? And the most famous one is your pi, which is your 3.14, that never ends and never ends and never ends. It also never doesn't repeat. Okay, and you have all of those are called irrational. Okay, so they're just the opposite of rational, the decimals that don't repeat and also never end. Okay, now as we are working with fractions, I do want us to be aware of the 3 ways that you can write a negative fraction. You'll see there's some that are more common than others. One of the ways would be negative 1/2 with the negative symbol out in front, like that. Similarly, you might have a negative 1/2 like this. Okay, so you have a negative 1/2 with the negative symbol written there. And then the last one, which is not common at all, and you may never really see it, would be the negative in the denominator like this. The most common and the easiest to use, let's go ahead and circle this one, is going to be this middle one here. It just makes it really clear where the negative symbol is and things like that, so you don't forget it. But all of those are valid ways. The one that is not, just to be aware of, is if you had negative 1/2, okay, like this, with the negative symbol on the top and the bottom. And that's because we know -1 divided by -2 ends up, because of hating to hate, ends up becoming positive. So this is not one of the ways to write a negative fraction. That's an entirely different problem. All right, so let's go down to comparing the rational number. We're going to use our normal inequality symbols that you're aware of. And what we want to do is, when comparing fractions, we have to make them be like each other, okay, in one form or another. And so we know that could be make them both look like decimals, or make them have the same denominator so they can be compared. Right now, they don't have common denominator, so we can't compare those. So let's go ahead and look at method number 1, which will be just change them to decimals. Now, if you're allowed to use a calculator, I mean, this is really the easiest method. You just do the -1 divided by 4, get a decimal, -2 divided by 9, get a decimal, done. Like, compare them, and you're all set. If you can't use a calculator, you're stuck either I know the common decimal, or you're doing the long division, or we are changing these to fractions if you think you can make a power of 10 in the denominator. So let's focus on the decimals first. The -1/4, I just know 1/4 is 0.25. And so that's a pretty familiar one. If you didn't, you could do the long division. So I'm going to just go ahead and write that out. So I have -0.25. Okay. Don't forget that these are all negative, so you don't want to lose that and forget it. All right, now -2/9, that's not as familiar to me. So unfortunately, I'm stuck doing the long division. I do want to put my negative here and the 0 so that I don't forget that it's negative. I'm going to go ahead and do the 2 divided by 9. So we'll just set it up real quick here. 2 divided by 9. I know that 9 times nothing gets me close to 2. So we'll extend on another 0 here. 2 times 9 is 18. Do my subtraction. I have 2 left over. Bring down the additional 0. 2 times 9 is 18. And we can see sort of this pattern that we're going to have a repeating decimal here. So I can see that this is 0.2 repeating. Okay. And so I'm going to go ahead and put this right here. Okay. Now, one of the things that I want to do right away is I notice that this has 2 place values to the right of the decimal point, and this only has 1. I always, when comparing, want to make sure that I have the same amount of digits. But like the mistake that you just saw me do there, we have to realize that we're not just putting zeros on as placeholders. Because this is repeating, this is what it would look like. But I do want those to look the same in order to compare them, okay? And then as we're comparing decimals, because they're negatives, that brings up a whole nother twist. So a couple things we're doing here. When we're comparing decimals, we talked about making sure that they have the same amount of digits in them to compare. You can think about decimals as money. So I have like 25 cents, or I have 22 cents. So I know 25 cents is more. But here's the twist with this, okay? Because they're negative, you sort of have to picture them on a number line or think about their absolute values. When they're negative, you can think about how much in debt you are. You can think about temperature is an easy one. So I look at those two numbers and I think, okay, I have 22 and 25. They're both negative, which is the warmer temperature. And so because the 22, let's say, degrees is the warmer temperature than negative 25 degrees, I know that this is my greater number. So notice how I make a note with that. I want to be really, really careful. And then I'm going to put my symbol here. So I have that note. Let's go ahead and change these to fractions. So the -1/4, I can take the 4 and turn it into 100. I know I can do -1/4 and multiply by 25 over 25. Okay, remember when we're multiplying by one whole, it's still the same number. And I can make hundreds, but I don't know how to turn the ninths into hundreds. And so that's going to be a little bit different there. So instead what I'm going to do, because I can't make both of them have a common denominator of 100, I'm going to choose to multiply each of them by a whole and just create equivalent fractions so that I can compare them. Okay, so let's go ahead and set these up. I'm not going to write it with the negative way out in front. I'm just going to write it like this. Like I said up top, it's a little easier to work with. So I have the -1/4, and I have the -2/9. Okay. Now what I'm going to do is I'm just going to, we could think about the smallest number possible and think about our least common multiples and things like that. But honestly, I'm just going for easy with this. I just need to make a common denominator. I don't really care about the rest of it here. So I'm just going to use each other's denominators, and I'm going to multiply by 9 over 9. And then I'm going to multiply by 4 over 4. Okay, and keep it nice and simple. So my equivalent fraction to this, 9 times the -1. I hate to love, so I hate. And 4 times 9 is 36. So here's my new fraction. And then we have 2 times 4 is 8. That's negative. And 4 times 9 is 36. Okay. Now all I have to do, because they have the same denominators, is just look at the numerators. And so again, because they're negative, think about it as temperature. Which is the warmer temperature? Well, -8 is definitely warmer. So I'm going to instantly draw my inequality symbol that shows that the -8 is greater. Okay. Now that I've shown that both of that work, I can go ahead and write my actual comparing statement with my original numbers. Okay. So my original number was -1/4 is less than -2/9. Okay. All right. The last part of this is ordering rational numbers, and they're having us go from least to greatest. So again, right away, what I usually do is I go down here and I write least so that I remember the order and don't make that mistake. I have to show work by making them similar or like each other. And so they all have to either become decimals, or I have to change them all to common denominator fractions, which would be crazy amount of work. There's no way I'm doing that. I'm just making them all be decimals. Okay. All right. So the first one that I see up here is already a decimal. So nice and easy. Okay. So that's done. 2/3. It is a common one that you're going to know eventually, but let's pretend that you don't for right now. So I would do a little 2 divided by 3 and solve that out. I know 3 times nothing gets me close to there, so we put our decimal point and put on another 0. 3 times 7 is 21, so that's a little too high. So 3 times 6 is 18. And then we subtract, and we have 2 left over. Okay, we're going to bring down another 0, and I end up with another 20 again. So you can see how this is going to go. 3 times 6 is 18, subtract, and I end up with a 2, and so on. So I can see that this is 0.6 repeating. Okay, and I'm looking at how many digits I have, and that only has 1 digit. So it seems like it's okay to just put the 0.6 repeating, and that's it. Okay, so far they're matching up because we talked about when you're comparing decimals, you want to have the same amount of digits that you're comparing. All right, but over here we have, that messes that up instantly. At least it's already written. So we have 3 digits, so I do want to make these have 3 digits as well. So because this is remember what's called terminating decimal, everything to the right is zeros. Okay, so I can go ahead and just put that. This next one, 2/3, is not a terminating. So everything after this is sixes, okay? So now I have these and I can easily compare, okay? All right, now we have -3/5. Don't forget that that's a negative. I don't know what 3/5 is as a decimal, but I can quickly change this into tenths so that I can recognize it as a decimal in the tenths place. So I'm going to go ahead and do that and multiply by 2/2, okay? And when we multiply by 1 whole, it's still the same number. Again, you may like writing it like that instead to make it visually nicer for you. So 3 times 2 is a -6, and 5 times 2 is 10. And so now I can just read that as -6/10. And so I have a -0 wholes and 6/10. Okay. It does terminate there. I know that I want 3 digits, so I'm going to go ahead and put those placeholders there. All right, and then my last one, I look at that and I go, okay, I don't know what that decimal is off the top of my head. Can I change it to a power of 10 or a multiple of 10? And I can definitely turn 25 into 100, okay? So I'm going to go ahead and do that because it's way nicer than doing the long division. So I'm going to multiply by 4/4 because I know there's 4 quarters in a dollar, okay? So there's my whole. And so I have -11 times 44. Or see, I'm thinking ahead. -11 times 4 is -44, and 25 times 4 is 100. So now if I read it, I have -44 hundredths, okay? So -0 and tenths, hundredths. I know the 4 has to end there, so there we go, 44 hundredths, okay? I want to have another placeholder there, so there we go, and that's the same number still, okay? It still reads 44 hundredths. All right, so now I have all my decimals written. They all have the same amount of digits, which is really going to make it nice to compare because I can sort of just read them as hundreds, 440, 600, that kind of thing. So it makes it a lot easier. So now what we want to do is we want to separate the positives and negatives. And the reason we want to do that is just so we don't accidentally, look at 666 and look at, this 600 and forget that one's positive, one's negative, and make a mistake with that. So I'm just going to find all my negatives, and I'm going to go ahead and highlight. So here's a negative, and here's a negative, and here's a negative. Okay, so I'm going to go ahead and put them down below, and just write them. I'm not going to worry about ordering them yet. Okay, if you wanted to sort of order those as you put them down there, you could. It'd make life, I guess, a little bit easier. I'm going to go ahead and just put them down, though. So 0, 500. I have a -0.600, and I have a -0.440. When I'm copying numbers, I usually just read them as the digits like that, so I make sure I don't make a mistake. All right, and then I have my positive numbers that I want to take notice of, and that's those two. Okay, so those two are going to go to positives, and we'll go ahead and record those down. Okay, so I have the 0.666, and I have 0.625. Okay, all right, now we want to be looking from least to greatest, and so let's take care of our negatives first because we know that those are going to be the least, and I want to find the temperature that is the coldest. Okay, and so what I'm going to do is I'm going to write them underneath here, and I'll explain why in a second. So I see that the -600 is the coldest, and then I would have the next coldest is this one here, and then the warmest of the three, if I'm thinking temperature, closest to 0 is this one. Now, the reason I'm writing them underneath is because it says in the directions that I have to order the original numbers. And this is an expectation I'm going to have of you for this unit and for the quizzes and tests, is you need to actually read those directions and follow that this time so you don't lose a point. So focus on those directions, following them precisely, and you'll be all set. All right, let's go ahead and get our positives, and then we'll write the originals last. Okay, so now I'm just thinking temperature again, which is the hottest temperature, and that is 0.666. And so we'll go ahead and put that there. And so that leaves us with the 625 thousandths as our last one. All right, now that we have that, we can write our actual original numbers. So I'm just going to look at this first one, and then I'm going to see that originally was no, that wasn't 2/3. That was originally, where's the 600? There it is. That was originally -3/5. Okay, I'm going to look at my 500 one and see that originally was -0.5. And then I'm going to look at this 440 one and see that it originally was -11/25. And you can write it with that negative in the numerator like that. That's fine. And then my 0.625 was originally 0.625. And then my 0.666 was originally the 2/3. Okay? So that's the process of getting those all ordered, and then from least to greatest with the original numbers. Okay? All right. Good luck with that. If you have any questions, let me know.